This section examines starter motor switching. The starter motor is usually brought into operation by activating a starter switch as part of ignition key operation. This remote control operates a starter-mounted solenoid which has two functions. It acts as a solenoid to engage the pinion with the flywheel ring gear, and it acts as a relay to bridge the main starting terminals. In the control circuit, the ignition lock start switch has a positive connection from the battery and a connection to two windings in the starter solenoid. One of these is a pull-in winding, which has a low resistance value, and the other is a hold-in winding, which has a high resistance. The pull-in winding is connected to the main starter terminal leading to the field and armature windings, and its circuit will be completed through the armature to ground on the starter casing and by frame return to the negative battery terminal. The hold-in winding is connected to ground on the starter casing. With the ignition key in the start position, current passes from the positive battery terminal through the start switch and through both windings. The high current flow through the low resistance pull-in winding creates a strong magnetic field which attracts the solenoid plunger towards the main terminals. Plunger movement also operates the shift fork lever, engaging the pinion with the ring gear. The plunger contacts a switching pin, which transfers the motion through a contact spring to a moving contact, which then bridges the main terminals. This allows a large current to flow from the battery through the starter motor windings, causing armature and pinion rotation and rotation of the engine crankshaft. Bridging the contacts also short-circuits the pull-in winding, and the plunger is held in position by the action of the hold-in winding only. The pull-in winding is short-circuited because battery voltage is now being applied to both sides of the winding, and this stops current flow through it. During engine cranking, the action of the helix on the rotating armature shaft causes the pinion to be forced as deeply as possible into the flywheel ring gear, and this holds the pinion in mesh. The hold-in winding is only used to ensure that the moving contact continues to bridge the main starter terminals. When the engine initially fires, the ring gear tries to drive the pinion and the force acting through the helix is relieved. When the starter switch is released, this opens the circuit between the battery and the hold-in winding, and current flow through the winding ceases. The return springs in the solenoid return the plunger, the moving contact, and the pinion to the rest position.